cold spot in space that defies every law of physics. Imagine looking at the sky and realizing the universe itself is broken. Not a star-gone supernova, not a black hole devouring everything nearby. Something far stranger, a place in space colder than it has any right to be, a scar in reality that should not exist. There is a region where the rules of physics seem to have paused, where light from the dawn of time itself betrays a quiet, impossible absence. When we look into deep space, we are not simply looking outward, we are looking backward. Every photon reaching our eyes is a message sent across time. Every faint glow carries a history older than humanity, older than Earth, older than the sun. Some of that light began its journey before planets existed, before stars settled into stable orbits, before the universe even learned how to organize itself. Hidden within that ancient light is a whisper, a background signal so old it predates galaxies, a cosmic afterimage from the moment the universe first became transparent, the oldest light we can possibly observe. It fills the entire sky, smooth, calm, almost perfectly uniform. Almost. Because when scientists finally mapped this ancient light in extreme detail, something felt wrong. One region of the sky did not match the rest. A subtle deviation at first, easy to miss, easy to dismiss. But the numbers did not lie. This region was colder than its surroundings. Not slightly colder, not within any acceptable margin of uncertainty, colder than the universe should allow. At first, skepticism was the natural response. Instruments are imperfect, data can be contaminated, noise can masquerade as meaning, cosmic measurements are delicate things vulnerable to error. So scientists waited, they refined their tools, they gathered more data, they measured again. And again. Each time the same result appeared. The cold region did not fade, it did not shrink, it did not dissolve into statistical noise. As the maps grew sharper, the anomaly became clearer. A vast patch of sky, immense, ancient, silent. It was not moving, it was not changing, it was simply there. A bruise on the universe that refused to heal. This light is not recent, it is not local, it is not tied to stars, galaxies, or cosmic structures that formed later. It is frozen into the universe's first moments, before complexity, before structure, before anything that could reasonably create such an imbalance. Nothing in that era should have been capable of carving out a region like this. Yet the cold spot exists. Not as theory, not as speculation, as observation. Embedded in the oldest light we will ever see. Which raises a question that cannot be ignored. If this imprint was placed there at the dawn of time, before galaxies, before stars, before planets, then what exactly caused it? And more unsettling still, what does it mean when the universe carries scars from a time when nothing should have been able to leave one? The universe should not look like this. The universe is not supposed to look like this. Everywhere else, the cosmic microwave background hums with a quiet uniformity, a perfect symmetry that stretches across billions of light years. Tiny ripples exist, yes, whispers from the infant universe, but they are supposed to be orderly, predictable, statistically inevitable. And then there is the cold spot. A blot of darkness on an otherwise flawless map. Its edges are not random, its shape is subtle, unnatural, almost deliberate. It pulses faintly as if the universe itself is breathing, but wrong, too slow, too deep, too quiet. At first, researchers suspected a fluke, a glitch in the instruments, noise masquerading as meaning, yet every refinement, every new survey only sharpened the anomaly. The cold spot persisted. It was a rule-breaking feature in a cosmos that should have none. The scale is staggering. Thousands of galaxies could fit inside it. Entire clusters swallowed into an emptiness that defies explanation. Light passes through it as if nothing exists, yet the region is not simply empty. It behaves as if space itself has been altered, distorted. The universe is meant to be uniform. Its earliest light should follow the patterns laid down by cosmic inflation, by gravity, by chance itself. But here, chance has failed. The rules have faltered. One region stands apart, a statistical impossibility staring back at us across 14 billion years. What caused it? Some say it could be an enormous void, a bubble of near-nothing stretching across unimaginable distances. Others hint at something stranger, something beyond the known universe, something that touches the edges of reality itself. And yet, the cold spot is ancient. It is frozen into the universe's first light, present before galaxies, before stars, before planets. It is not a late anomaly. It is woven into the fabric of the cosmos from the very beginning. The mind struggles to comprehend the implications. If the universe can behave this way, if a single feature can defy all expectations, then our understanding of cosmic history is incomplete. Our models, the equations that describe everything from galaxy formation to the expansion of space itself, are being challenged. The cold spot is a contradiction, a question written across the sky, a warning. And it is not done speaking. What force, what event could leave a scar so deep that it survives unaltered for nearly 14 billion years? And if this anomaly is real, then what else lies hidden in the universe's oldest light, waiting to shatter our assumptions? The answers, if they exist, may force us to rethink the nature of reality itself. The oldest light we can see. To understand the cold spot, we must travel backward, not just across space, but across time itself. Every photon we see today is a messenger from a past that no human has ever witnessed. Light that began its journey when the universe was less than 500,000 years old. Light that has drifted across the vast emptiness of space for nearly 14 billion years, untouched, unchanged, carrying the memory of creation itself. Imagine rewinding the universe. Galaxies collapse back into clouds of gas, stars unignite, leaving darkness, entire clusters of matter retract into nothingness, space itself contracts, folding in on itself as the cosmic clock runs in reverse. And in this reversal, we arrive at the era of the cosmic microwave background, the afterglow of the Big Bang. It is a time before structure, before planets, before even galaxies had formed. The universe was a hot, dense plasma, a glowing sea of particles that danced in perfect, violent harmony. And yet, even here, the cold spot is visible. It is embedded in the universe's first light, frozen into the very fabric of space as it cooled, a subtle but undeniable scar on the canvas of reality. This is not a feature that formed later. It was already there from the beginning. The scale is incomprehensible. Billions of light years across, far larger than any void or supercluster we have observed. The cold spot stretches so wide that imagining its size challenges the mind itself, and its temperature is lower than physics says should exist in such a uniform early cosmos. What could have caused it? No known process in the young universe has the power or the reach to produce such a feature. It is too massive, too deep, too precise. It is as if some invisible hand shaped the primordial plasma, leaving a faint but permanent mark. This is the oldest light we can observe, the universe's original photograph. And in that photograph, the cold spot stares back at us, silent and unyielding. It is a relic of something vast, ancient, and unexplainable. The implications are staggering. If the universe carried this imperfection from its earliest moments, then our models of cosmic inflation, of how matter and energy settled into the patterns we see today, are incomplete. Something disrupted the smooth, predictable evolution of the cosmos. Something left a bruise before the first stars ever formed. And the deeper question emerges. If the cold spot existed when the universe was still learning to organize itself, what force, what event, what mechanism could reach across all of space at that time and leave behind a scar so enduring? And if such a force exists, is it unique, or is it a glimpse of something even more terrifying lurking beyond our understanding, hidden in the light of the universe itself? The oldest light we can see is whispering secrets, and the cold spot may be the first clue. The scar from before time. The cold spot is older than anything we can name. It predates galaxies, it predates stars, it predates planets. It existed when the universe was little more than a swirling, searing fog of energy and light. And yet it carries a memory. A bruise left across space itself, a distortion frozen into the very fabric of reality, subtle, almost imperceptible, but undeniable. A scar from before time had fully begun. Imagine the early universe as a canvas of pure possibility. Every point of space vibrating with potential, every particle tracing the outlines of what would become galaxies, clusters, civilizations. Everything is forming, unbroken, seamless. And then there is a flaw, a rupture, a place that does not belong, a region colder than physics allows. The cold spot deepens in our maps. Its edges ripple like a barely audible pulse across space, as if the universe itself is trying to breathe around it. And the deeper we peer, the stranger it becomes. Some suggest that it is nothing, a void, a region emptied of matter, of energy, of anything that might leave a trace. But emptiness alone cannot explain the magnitude, the scale, the way this feature is etched into the oldest light we can observe. Something violent must have acted, yet there is no evidence of debris, no shrapnel of collapsed structures, no aftereffects, only silence and cold. It is as if some ancient event, older than time as we know it, reached across the infant universe and left its mark. A force that predates stars, galaxies, and even the familiar laws of physics. A disturbance so fundamental that the universe itself carries its memory today, 14 billion years later. The scar is more than a curiosity, it is a warning. It tells us that the cosmos is not entirely safe, not entirely predictable. That order is fragile, that something somewhere has the power to alter the fundamental rhythm of reality. And the question begins to twist in the mind. If this scar exists from the dawn of time, what could have created it? What force could reach across the newborn universe, imprinting a disturbance that no subsequent evolution could erase? And darker still, what does it say about the universe we inhabit now? For if the universe could be wounded before structure even formed, if the very light of creation can carry evidence of an event so immense and alien, then perhaps our understanding of existence is incomplete. Perhaps the laws we trust, the constants we measure, are only temporary rules, fragile guidelines in a cosmos capable of being rewritten. The cold spot is not just cold, it is a message, and it is far older than any civilization could decipher. A scar from before time, waiting to tell us the truth about the universe we thought we understood. The first explanation failed. When the cold spot first appeared in the maps of the early universe, scientists reached for explanations they trusted. It had to be something familiar, an error in the instruments, a statistical fluke, cosmic noise masquerading as significance, anything but a fundamental challenge to everything we thought we understood. But every experiment, every simulation, every painstaking calculation told the same story. The cold spot was real. It refused to vanish. It resisted every model we applied. The equations faded on the screen as researchers tried to force them to fit reality. Simulations ran again and again, each time producing universes that looked nothing like the one we inhabit. The anomaly persisted, stubborn, unyielding, impossible to ignore. This was not just a problem for cosmology, it was a fracture in authority itself. The experts, the equations, the decades of observations, all had built a framework meant to describe the cosmos. And yet, here was a feature that none could predict, none could explain, none could contain. The cold spot is so vast, so anomalous, that it challenges the very foundation of how the universe should behave. Our best models, those that explain the growth of galaxies, the formation of clusters, the distribution of matter across billions of light years, simply fail when confronted with it. Some suggested an enormous void could cause it, perhaps a region almost entirely empty, stretching across unimaginable distances, but even that explanation collapses under scrutiny. The void required is larger than anything inflationary cosmology predicts. Its size violates the statistical rules of cosmic structure formation. The cold spot is not only cold, it is too big, too precise, too unnatural. The deeper scientists probe, the more unsettling the picture becomes. The universe is not behaving according to our expectations. It has a memory we cannot fully comprehend, a memory that existed before galaxies, before stars, before the familiar patterns of matter emerged. And if our best explanations fail, then what remains? We are forced to confront uncomfortable possibilities. Could it be evidence of something beyond our universe? A collision, a ripple from another reality brushing against ours at the dawn of time, or an unknown process operating on cosmic scales, something capable of reaching across billions of light years in the universe's infancy? The cold spot refuses to conform. It does not explain itself. It does not apologize for existing. It simply is. And in its stubborn existence lies a profound lesson. The universe is stranger than our models, larger than our imagination, and far less predictable than we are comfortable admitting. If our instruments and equations cannot contain it, then we must confront the unsettling truth. Perhaps this anomaly is only the beginning. What else might exist beyond the reach of our understanding, waiting in the oldest light of the cosmos to challenge everything we think we know? The largest void ever found. Somewhere in the vastness of space, there exists a region that should not exist. A void so immense that imagining it stretches the mind to its limits. Galaxies thin out and vanish. Clusters of stars disappear into emptiness. Light itself seems to hesitate before entering this place, as if the universe is warning us that nothing normal resides here. Could the cold spot be caused by such a void? The idea is tempting. After all, empty space cools the cosmic microwave background. A vast expanse of near nothing could produce the subtle cold we observe. But the scale required is unprecedented. It is so large that it defies the rules of structure formation. Nothing this enormous should exist according to everything we know about cosmic evolution. Imagine flying through this emptiness. The Milky Way recedes into the distance. The local group of galaxies disappears. The universe itself becomes silent, devoid of the familiar clusters and filaments that give it shape. And yet the void continues, stretching across billions of light years, almost unimaginably vast. This is not simple emptiness. This is a vacuum of scale, a cosmic absence that dwarfs the structures we take for granted. It is spatial isolation writ across the sky, and within it the cold spot pulses, subtle but undeniable. Astronomers call it the largest void ever found, but calling it a void understates the terror it inspires. The universe is supposed to organize itself, to form patterns, to obey statistical rules, and yet here at this scale the universe breaks those rules. If this emptiness can exist, then the cosmos is stranger than we ever imagined. Its structure is not entirely predictable. Its history is not entirely knowable. And the cold spot is the signpost, pointing to a place where the ordinary laws of physics may bend or falter. The scale of the void makes it impossible to ignore. It dominates the sky, it challenges our assumptions, and it raises a chilling question. If the universe can contain a region this empty, this massive, what other surprises lie hidden in the cosmic landscape? And if such emptiness is possible, then what else is the cold spot telling us quietly across 14 billion years of light? Nothing this big should exist. Nothing this large should exist in the universe. The void implied by the cold spot is not just empty. It is an affront to every principle we hold about cosmic structure. According to our models, gravity and the expansion of space should produce clusters, filaments, and walls. Matter organizes itself over billions of light years into a web of order. Chaos becomes structure. And yet, here is a region that refuses all of that. Imagine the Milky Way shrinking into the distance, then the local group, then entire superclusters. They vanish into a nothingness so vast that the human mind struggles to comprehend the scale. The void swallows everything familiar. Time and space stretch over billions of light years, as if the universe itself is holding its breath. Statistical rules that govern the formation of galaxies, the growth of clusters, the distribution of matter, all fail when confronted with this emptiness. A cosmic improbability so extreme that simulations almost never produce anything like it. Almost, but not entirely. Rare, but undeniable. The cold spot sits at the heart of this void, subtle, persistent, and wrong. Its temperature is lower than expected. Its size is far beyond what the models predict. The universe has broken its own rules. And the implications are staggering. If nothing this big should exist, then our understanding of the cosmos is incomplete. The laws of physics, the equations that predict cosmic evolution, the frameworks we trust to describe reality, all have blind spots. The cold spot is one of them. It forces us to reconsider what is possible, not just locally, not just in a galaxy or cluster, but across the universe itself. It forces us to ask questions we are not ready to answer. Could the cold spot be more than emptiness? Could it hint at something beyond, something massive, unseen, or unfathomable? The void is enormous. Its emptiness is terrifying. And at its center, the cold spot silently pulses, reminding us that the universe still holds secrets far larger, far older, and far stranger than we have dared to imagine. If nothing this big should exist, then what else might the universe be hiding, quietly breaking the rules we thought were absolute? What if it's not empty? The most dangerous moment in any investigation is when a comfortable explanation collapses. For a while, emptiness felt safe. A void, no matter how enormous, still belonged to the universe we understood. Empty space could be measured, modeled, contained by equations. Even terror was easier to tolerate when it had a name. But then the data began to whisper something else. What if the cold spot is not empty at all? What if the universe is not cooling there because nothing exists, but because something does? As observations deepened, subtle inconsistencies emerged. The void explanation began to strain under its own weight. The shape was wrong. The temperature profile did not behave the way emptiness should. The cold spot did not fade smoothly into its surroundings. It distorted them. Light passing through the region behaves strangely, not dramatically, not violently, but enough to raise alarms in the minds of those who know how light is supposed to travel through space. It bends just a little too much. It cools just a little too deeply. It carries a signature that does not align with absence. The void darkens in simulations, not because it is empty, but because something unseen may be influencing space itself. And that is when fear replaces curiosity. Because emptiness cannot reach out, nothing cannot disturb the structure of the universe, but something can. The cold spot begins to feel less like a hole and more like a presence, a region where spacetime itself behaves differently, where the background fabric of reality is subtly warped, where the universe does not quite follow the same rules it follows everywhere else. This possibility changes everything. If the cold spot is not caused by missing matter, then it may be caused by excess, not of particles, not of energy we can detect, but of something more fundamental, something that interacts with space without revealing itself directly. Something massive, ancient, silent. And the deeper implication settles in slowly. If something exists there, then it has existed since the dawn of time. It was present when the universe was young, when light first broke free, when reality was still fragile and unfinished. Whatever it is older than galaxies, older than stars, older than the laws we currently use to describe the cosmos. The idea is unsettling because it reframes the cold spot completely. This is no longer a passive absence. It is an active distortion, a place where the universe remembers an interaction it should not have survived unchanged. The ripples around the region are subtle but persistent, like water disturbed by an object just beneath the surface. You cannot see it clearly, but you know something is there because the surface will not stay still. And if that is true, then the cold spot is not just a feature of our universe. It may be a boundary, a place where our universe brushed against something else. Something not made of our matter, not governed by our physics, not confined to our cosmic history. The question shifts again, becoming heavier, more dangerous. If the cold spot is not empty, then what is it connected to? And more terrifying still, if something has been touching our universe since the beginning, then how many other places like this exist, quietly distorting reality, unseen, waiting to be noticed? The answer may lie beyond our universe entirely. A collision with another universe. There is a moment when speculation stops feeling abstract and starts feeling dangerous. Because once you accept that the cold spot may not be empty, the mind is forced toward a possibility that changes everything. What if our universe was not alone at its birth? Modern cosmology allows for a staggering idea that our universe may be only one bubble in a vast cosmic foam, countless universes expanding, forming, and drifting through a higher dimensional space, most forever isolated, some never touching, but occasionally, impossibly, two might collide. Not violently, not like an explosion. More like a bruise. Imagine two expanding universes brushing against one another in the earliest moments of time. No fire, no sound, just a subtle interaction at the boundary, a pressure, a distortion, a transfer of energy that leaves behind a permanent mark. The cold spot fits that description too well. In simulations, when two universes interact, they do not tear each other apart. They leave imprints, regions where temperature drops, where symmetry breaks, where the fabric of spacetime remembers a contact it cannot erase. A cosmic fingerprint. If this is what we are seeing, then the cold spot is not a flaw in our universe. It is evidence of another one. A universe that once pressed against ours, altered its structure, and then drifted away, gone forever, unreachable, leaving behind nothing but a faint cold region in the oldest light we can see. The scale of this idea is dizzying. It means the cold spot is not just a local anomaly. It is a boundary between realities, a place where our universe encountered something beyond itself. And if that happened once, then it could have happened elsewhere. The universe suddenly feels larger than space, larger than time, larger than anything we can observe directly. Our cosmos becomes one chapter in a story we cannot fully read. But all quickly turns to unease, because collisions leave consequences. If another universe touched ours at the beginning of time, then the laws of physics we experience may not be universal at all. They may be local, contingent, shaped by ancient interactions we barely survived. Constants we treat as fundamental may be scars of that encounter, the balance between forces, the rate of expansion, even the possibility of stars, planets, and life itself. The cold spot may be the place where those rules were negotiated. And that realization brings a darker question into focus. If universes can collide, then what prevents it from happening again? What protects us from future interactions we cannot predict, cannot detect, and cannot survive? Because if reality itself can be bruised, then nothing we know is truly stable. And the cold spot is not just evidence of another universe. It may be a warning left behind by a collision we were never meant to discover. The experiment that could break reality. At some point, mystery becomes temptation. Because once a possibility exists, scientists cannot look away. They design instruments, they sharpen questions, they point humanity's most sensitive machines directly at the wound in the sky. The cold spot is no longer just something we observe. It becomes something we interrogate. Across decades, satellites have mapped the oldest light in the universe with terrifying precision. Each new mission peels back another layer, tiny fluctuations measured to 1 part in 100,000, patterns that should not be there slowly emerging from the noise. And the cold spot refuses to disappear. Instead, it sharpens. Statistical flukes fade with better data, instrument errors correct themselves, random noise smooths out, but the cold spot grows more stubborn, more defined, more real. This is where discomfort sets in. Because now the question is no longer whether the cold spot exists. The question is what kind of universe allows it to exist at all. Physicists begin testing the idea in the only way they can, by asking whether the cold spot obeys the rules of cosmic inflation, the rapid expansion that smoothed the early universe into near perfection. It should not survive inflation. Anything this large, this cold, this coherent should have been erased, flattened, diluted into statistical nothingness. But it was. That forces an unsettling conclusion. Either our understanding of the universe's earliest moments is incomplete, or the cold spot was formed by something inflation could not erase. Something external. And that changes the role of the cold spot entirely. It stops being a passive anomaly and becomes an active test. A place where competing theories of reality collide, void models. Exotic physics, multiverse collisions, each makes predictions, subtle differences in polarization, in temperature gradients, in how surrounding galaxies move. The cold spot becomes a courtroom, and the universe itself is on trial. But experiments come with risks. Not physical risks, existential ones. Because every measurement that leans away from randomness pushes us closer to a universe that is not self-contained. A universe shaped by forces beyond its own beginning. And that idea destabilizes more than cosmology. It destabilizes meaning. If our universe is just one outcome among countless others shaped by collisions and chance interactions, then necessity disappears. There is no guarantee that anything had to exist the way it does. Stars become accidents, chemistry becomes coincidence, life becomes a statistical miracle balanced on a knife edge of cosmic history. And suddenly, the cold spot feels less like a scientific curiosity and more like a reminder of how fragile reality is. We are not living in a perfectly tuned universe. We are living in a universe that survived something. And survival implies vulnerability. Because if the cold spot is evidence of a past interaction, then the cosmos may still be a crowded place. Other universes may still be forming, expanding, drifting through dimensions we cannot access. Invisible, untouchable. Until they are not. So the experiments continue, the maps grow sharper, the data accumulates. And with every new observation, we inch closer to an answer that could redefine everything. But one question looms larger than all the rest. If the cold spot is proof that reality can be altered from the outside, how would we ever know if it is about to happen again? A scar, not a shadow. There is a moment in every investigation when a mystery stops behaving like an illusion. When it refuses to blur away, no matter how closely you stare. That moment has already passed. Because the cold spot does not fade with scrutiny, it deepens, it acquires structure, it begins to look less like a shadow and more like a wound. Across the cosmic map, the surrounding regions tell a story that should not exist. Galaxies thin out as they approach it. Gravitational patterns subtly bend away as if something once pushed outward from that point and never fully let go. This is not how empty space behaves. A simple void should be passive, it should be quiet, it should merely lack matter, but the cold spot feels active as though it carries memory, as though something happened there that the universe has not finished processing. This realization changes everything. Physicists stop asking whether the cold spot is rare and begin asking whether it is historical. Not a random fluctuation, but an event frozen in time, a scar imprinted on the fabric of reality itself. Scars imply trauma. They imply force, pressure, impact. And the scale of this one is almost impossible to comprehend. The cold spot spans a region of space so vast that light takes billions of years to cross it. Whatever caused it would have operated at energies beyond anything we can recreate, beyond anything our equations were designed to survive. This is where the language of science begins to sound uncomfortably like the language of catastrophe. Some models suggest a collision, not between galaxies or clusters, but between entire regions of spacetime. A brushing contact between universes during the earliest moments of existence. A glancing blow that did not destroy us but altered us. If that sounds absurd, consider the alternative. That our universe spontaneously generated a feature this large, this coherent, this resistant to explanation without any external cause at all. One possibility challenges our imagination. The other challenges the laws of physics. Neither option is comforting. The cold spot begins to feel less like a question mark and more like evidence. Evidence that the universe we inhabit is not isolated, that it has neighbors, that it may have a history of encounters we barely survived. And that realization triggers a deeper unease. Because scars do not appear without consequences. They change structure, they weaken integrity, they mark locations where failure is more likely to happen again. If spacetime can be damaged even slightly, then the universe is not immutable. It is not eternally stable. It is something that can be disturbed, deformed, reshaped. And we're living inside it. The cold spot might not be a remnant of chaos long past. It might be a warning that the boundaries of our universe are thinner than we think. That reality itself can be touched. So the question shifts once more, growing darker with every turn. If the cold spot is a scar left by a cosmic encounter, what does that say about the safety of the universe we still call home? The Fermi paradox stops being abstract. The silence of the universe used to feel theoretical. A curiosity, a puzzle for late nights and chalkboards, a question framed politely as wonder, where is everybody? But standing in the shadow of the cold spot, that silence stops feeling philosophical. It starts feeling deliberate. For decades, we assumed the cosmos should be loud. Billions of galaxies, trillions of planets, civilizations older than Earth by millions, even billions of years. Some should be broadcasting, some should leave traces, artifacts, signals, structures that announce intelligence long after its creators are gone. Yet the sky remains quiet. Not quiet like a forest at dawn, quiet like an abandoned city. At first, these two mysteries lived separate lives. The cold spot belonged to cosmology. The Fermi paradox belonged to speculation. One dealt with temperature maps and ancient light, the other with radio telescopes and unanswered listening. Now they begin to overlap. The cold spot is not just cold, it is empty in a way that feels structured. It sits in a universe that otherwise follows statistical rules. A universe where randomness averages out, where large scales smooth into uniformity. Except here. And the silence of the cosmos follows the same pattern, not random, not noisy, uniformly quiet. This is where discomfort turns into unease. If civilizations rise and fall independently, their remnants should overlap. Their signals should collide. The universe should hum with echoes of progress and collapse layered on top of each other. Instead, it behaves as if something keeps resetting the board. The cold spot becomes impossible to ignore in this context. It represents a place where the universe itself looks altered, where structure did not form as expected, where development stalled before it could begin. What if that pattern is not limited to matter? What if it applies to intelligence? Suddenly, the question is no longer why we have not found anyone. The question becomes why no one seems to last. The same universe that permits galaxies to grow appears hostile to complexity that persists. As if there are thresholds you can reach but not cross. As if advancement itself triggers conditions that erase the evidence. No explosions, no ruins, no warnings. Just absence. The cold spot offers a terrifying metaphor. A region where energy should be evenly distributed but is not, where something interfered early and permanently, where recovery never happened. Now imagine that principle applied not to radiation, but to civilizations. A universe where intelligence emerges, spreads, innovates, and then encounters a boundary condition it cannot see until it is too late. A filter embedded not in biology or technology, but in the fabric of reality itself. The silence stops being mysterious. It becomes consistent. And consistency is far more disturbing than chaos. Because it implies rules. Rules we do not understand. Rules we might already be approaching. The cold spot does not broadcast danger. It does not glow or scream. It simply exists as proof that the universe can erase outcomes without violence, without spectacle, without leaving a trail we know how to follow. If intelligence can be erased the same way, then the universe would look exactly like this. Vast, beautiful, empty. And suddenly, the Fermi paradox is no longer a question about aliens. It is a question about survival. If the universe has mechanisms that suppress complexity, then the absence of others is not evidence of rarity. It is evidence of selection. And the most unsettling thought is not that something out there destroyed them. It is that whatever did it left no sign we can recognize. Just silence. Just cold. Just a sky that looks normal until you learn where to stare. So the question tightens its grip. If the universe already shows us what erased its own past structures, how long before it turns that same indifference toward intelligence that grows too visible to ignore? The great filter might be behind us or ahead. There is a point in every long journey where the path narrows. Behind you lies everything that was possible. Ahead of you only what is allowed. Cosmologists call this idea the great filter, not as a theory of doom but as a quiet admission of ignorance. Something somewhere dramatically reduces the number of civilizations that make it from simple chemistry to lasting cosmic presence. Most never pass it. The terrifying part is not that the filter exists, it is that we do not know where it is. It could be behind us, hidden in the unlikely chain of events that turned lifeless matter into conscious observers, the precise chemistry of early Earth, the fragile stability of our star, the narrow window in which intelligence emerged at all. If that is true, then humanity is rare beyond comprehension, a statistical miracle balanced on a knife edge, alone but lucky. That version of the universe is cold but survivable. The other version is not, because the filter could also be ahead. And the cold spot forces us to confront that possibility with fresh urgency. Look again at what it represents: a region of the universe that did not develop as expected, where normal growth was interrupted early and permanently, where complexity failed to accumulate. In the cosmic timeline, the cold spot is not recent. It is ancient. Whatever caused it happened near the beginning, before galaxies fully formed, before stars found stable homes, before planets ever had a chance. It is a reminder that the universe does not guarantee progression. Now map that logic onto intelligence. Civilizations may rise naturally wherever conditions allow. They may discover energy, computation, communication. They may look outward, confident that growth is inevitable. And then something intervenes. Not necessarily an external enemy, not a war, not a catastrophe we would dramatize, but a boundary, a condition baked into reality that punishes complexity past a certain scale. The great filter in this light stops being a metaphor. It becomes a pattern. The cold spot shows us that the universe can impose limits without explanation, without warning, without repair. If the filter lies ahead, then intelligence does not disappear randomly, it disappears consistently. That consistency explains the silence. Not because civilizations fail to emerge, but because none are allowed to persist long enough to overlap. Each one believes it is early, each one believes it is special, each one looks out into a quiet sky and assumes it is alone. Until it is not. Until it reaches the threshold. The most disturbing implication is this: the great filter may not be violent. It may not announce itself with destruction. It may simply prevent further expansion, limit energy use, collapse communication, destabilize systems that scale too far too fast. From the inside, it would feel like bad luck, economic failure, technological stagnation, environmental collapse, unsolvable complexity. From the outside, it would leave no trace. Just another quiet star system. The cold spot hints that the universe has done this before, on scales so vast we struggle to imagine them, entire regions frozen out of normal development by something we still cannot name. If such mechanisms exist at the cosmological level, why assume intelligence is exempt? The universe has no obligation to nurture awareness. It only permits it briefly. So the question becomes unavoidable. If the great filter is behind us, we are the survivors of an impossible gauntlet. If it is ahead, then every step forward carries unseen risk. Both answers are horrifying. One makes us alone. The other makes us temporary. And the cold spot stands as silent testimony that the universe does not hesitate to erase futures that violate its deeper rules. Which raises the most dangerous question of all. If intelligence triggers the filter, what stage are we already approaching? The most terrifying possibility. The cold spot does not look dangerous. That may be its most unsettling feature. There is no explosion, no radiation spike, no violent signature screaming catastrophe, just a quiet absence embedded in the oldest light in existence. A region where the universe cooled a little too much, a little too early, and never fully recovered. If this were a wound, it healed badly. And that is where the fear sharpens. Because whatever caused it did not need to destroy the universe, it only needed to interfere once, a brief interaction, a slight deviation, a nudge that altered the trajectory of everything that followed. The damage was permanent. Now consider the possibility we have avoided until now. What if the cold spot is not a natural fluctuation? What if it is not the result of emptiness, chance, or early instability? What if it is evidence of intention? Not intention in the human sense, not malice, not planning as we understand it, but agency, interaction, a process that does not belong solely to our universe. A collision. If inflation produced multiple universes expanding like bubbles in an unseen medium, then contact is not impossible. two realities brushing against each other, one slightly denser, one slightly hotter, one leaving a mark on the other. The cold spot fits the signature, a bruise from another universe touching ours. This idea is not science fiction dressed as science. It emerges reluctantly after simpler explanations fail, after statistics, voids, and chance are exhausted, after the models refuse to comply. But here is the part that keeps physicists awake. If universes can touch, then isolation is an illusion. And if interaction is possible once, it is possible again. The cold spot would then represent proof that the laws governing our reality are not sealed, that the constants we treat as sacred may be local rules, not universal ones. Stability becomes temporary. Safety becomes conditional. The universe stops being a closed system and starts behaving like a shared space. And in such a space, intelligence is no longer just a biological accident. It becomes a variable. Advanced civilizations manipulate energy, they reshape spacetime, they probe boundaries we barely understand. If universes can interact naturally, then sufficiently advanced intelligence might learn to do so deliberately. At that point, the great filter takes on a new dimension. Civilizations may not be destroyed by disasters or internal collapse. They may attract attention, not from hostile beings but from deeper physical processes, from interactions that destabilize regions of reality, from experiments that brush against structures larger than galaxies. The cold spot could be a warning written in the oldest language the universe has. Do not push too hard. Do not grow too fast. Do not assume you are alone just because you hear nothing back. The most terrifying implication is not that something is watching. It is that the universe responds. Silently, impersonally, with no regard for intention. The cold spot does not threaten us directly, it does something worse. It demonstrates that reality can be altered in ways we do not control, by mechanisms we barely perceive, leaving scars that last for billions of years. And if that is true, then the silence of the cosmos is not comforting. It is compliance. It is what happens when nothing survives long enough to leave a reply. So the final question is not whether the cold spot is dangerous. It is whether it is unique. Because if it is not, then the universe has done this before. And it may do it again. Not with fire, not with noise, but with quiet, irreversible absence. If this question unsettled you, you're not alone. There are more stories like this hiding in the fabric of reality, anomalies that shouldn't exist, patterns that refuse to explain themselves, places where physics, philosophy, and fear quietly overlap. If you want to keep exploring them, stay here. Subscribe. And if this journey made you pause, share it with someone who won't forget it. Because the universe is full of things we were never meant to notice.